Okay, so we're going to use Desmos to graph. We've been using Desmos for lines, and now we're going to use them for parabolas. So you're going to go to desmos.com/calculator. And you're going to graph this equation, y equals 2x, or y equals x squared plus 2x plus 1. What's the fancy name for this graph again? Starts with a P. Parabola, yeah. So remember, a parabola usually has a y-intercept. Almost, it should every time have a y-intercept. It could have a couple x-intercepts. It could have one x-intercept. It could have no x-intercepts. And what's that minimum or maximum point called? Starts with a V. Vertex. Cool. So you're going to be asked to graph these on Delta Math. So to graph them for right now, all we know how to do is graph them on Desmos. So after you type in the equation, you're going to click the gear, and you're going to click this little button here that says Convert to Table, and it's going to give you a table. So what's handy about that is now you have some points from the parabola. A lot of times they'll ask you for the vertex, so you can just click on it to find the vertex, or you can look here and see if you can find the number that stands out as the vertex. You can also add your own numbers if you need more numbers. So if you're on Delta Math and they ask you to graph a parabola, all you need to do is put it in here and convert it to a table, and then take the points from this table and put it back in Delta Math. So let's see what I mean by that. So this one says, graph the equation. You must plot 5 points, including the roots and the vertex. So let's output that in our Desmos. Y equals x squared minus 10x plus 16. Y equals x squared minus 10x plus 16. Y equals x squared minus 10x plus 16. And Delta Math says that they want at least 5 points, including the roots and the vertex. So remember, the roots are the points where it hits the x-axis. So right there, we have 2 of our points already. The vertex is right there. So that's 3 of the points we need. We just need 2 more points. So let's convert this to a table and then find 2 more points that we can use. How about 1, 7, which is right there. 2, 0, we already have that. 0, 16. A lot of these numbers are not very helpful because they're too big for our graphs. We might need to add some more numbers like that. All right, so let's use 2, 0, which is right there. Let's use 8, 0, which is right there. The vertex we said was 5, negative 9. And then we need 2 more. 4, negative 8 looks good to me. Remember, we said these are symmetrical, so if I know this point and I know this point, I could just go like this and say that's also a point, right? Because I know that's the vertex, so if there's a point up 1 and to the left of the vertex, there'd also be one up and to the right. Let's confirm that 6, negative 8. Is that a point? 6, negative 8. Yes, it is. Cool. So in Delta Math, they just want you to graph it like that and then submit. And there you go. When they show you the answer, they're going to show you that they made a table of values. They're going to say they did not use a calculator to do this. They're going to say that they actually wrote out the equation and plugged in a bunch of numbers. but you guys can use your calculators. Cool? All right, let me stop recording. What's up, Mr. Matthews?